Alright, today we're going to do theoretical probability of compound events. So we have this bag of marbles again. Inside our bag we have some red, some yellow, and some blue. So I'm going to go ahead and make the table. So for red we have 2 that are red, 1, 2. Yellow we have 1, and blue we have 2. 1, 2. Okay, sorry I didn't give you, whoa, that is not focused. Okay, I didn't give you time to go ahead and set your paper up. Sorry about that. Okay, so theoretical probability of compound events, title your page. If you remember, if you don't have the colors, you can just draw a circle and inside put the letters. So you could do R, Y, and B for the different colors. This is the table we're going to work with first, independent, and we're going to be pulling 1 marble. We're going to replace it back into the bag, and then we're going to pull a second marble. Okay, we need more time. Pause the video. Okay, so how many total marbles do we have? We have 5 total marbles, okay? So if this was a simple event, there would be 5 possibilities if it was a simple event, okay? But this is a compound event. Compound means more than one thing is going on, okay? So this is the 2 things that are going on. We're pulling a marble out of the bag. Then we're going to put the marble back in the bag, and we're going to pull a second marble. Okay, so we have 5 options on the first round. So like round 1, we have 5 options. And on round 2, we also have 5 options because we're putting the thing back in the bag. And remember, to figure out the total outcomes of events that have more than one thing going on, we go ahead and multiply to get that. So there's 5 on the first round, 5 on the second round. So 5 times 5 is 25. So there are 25 total outcomes possible. Now some of those could be red on the first round, yellow on the second. Red on the first round, red on the second. Yellow on the first round, blue on the second. Yellow first, then red. I mean, there's 25 different kind of outcomes. Okay, but we're just going to find the probability of some of those options. Okay, so here we go. So what's the probability that comes out to be red and red? Okay, now, and in probability. From the last video, we saw that or meant to add, right? But and means to multiply. Now we can see that because remember how we had to multiply to get the total outcomes? So in order to get this denominator, we had to multiply. So we're going to have to also multiply the numerators. So what's the probability that it comes out to be red on the first round? Well, that is 2 red out of 5 total. Now we're going to multiply that by red on the second round. Remember, we put it back in the bag, and we're going to pull another red. Well, the probability that be red on the second round is 2 out of 5. The probability that be red together like that would be 2 times 2, which is 4, and 5 times 5 is 25. So it would be a 4 out of 25 chances. Because remember, there's 25 total outcomes, so that's the denominator that I needed. Or to get that denominator, we multiply. So we have to multiply the numerators. So that's the process. So it's 4 out of 25. And remember, to change these into decimal and percent, we need a number out of 100. Okay, so to remember to make this out of 100, 25 times 4 makes 100. So 4 times 4 is 16. So that would be 0.16, because that's 16 hundredths. The number out of 100 is percent, 16%. Remember, the original fraction was 4 out of 25, though. Okay? All right, let's do red and yellow. So what's the probability that was red? It would be 2 out of the 5 options. And then yellow is 1 out of the 5 options. So we're going to multiply that. 2 times 1 is 2. 5 times 5, 25. Can't simplify, so that's our fraction. Now I'm going to change it to a number out of 100 for our decimal percent. 25 times 100 is 4. Wait, sorry. 25 times 4 makes 100. So 2 times 4 is 8. So 8 hundredths to write that. We got to put the 8 in the hundredths place. So it's 0.08. And that percent would be 8%. Remember, this was our fraction. So all we're doing is taking the probability that one thing would occur and multiplying it by the probability that the other would occur. All right, let's do blue and blue. So there were 2 blues out of 5 total. So 2 out of 5. times, and then blue is 2 out of 5 again. So 2 times 2 is 4, 5 times 5 is 25. Oh, that was the same as the red, so I can just go ahead and write the decimal there, 0.16 and 16%. So that's the same likelihood. To get a blue is the same likelihood to get as a red, because it's the same amount in there. Okay, what about yellow and blue? So yellow was 1 out of 25, and blue was, my bad. It was a 1 out of 5, and blue is 2 out of 5. So 1 times 2 is 2, and 5 times 5 is 25. Oh, and that's the same as red and yellow. So 0.08 and 8%. Those are all simplified fractions, by the way. Ooh, this one's now it's tricky. Not blue and then get a yellow. Remember, for not blue, we have to do that subtraction. So how many are not blue? Well, 2 are blue out of 5. So how many are not blue? 3. So 3 out of 5. And then yellow is 1 out of 5. Just go to multiply. 3 times 1 is 3. 5 times 5, 25. Oh, did we have that one? No, we did not. Okay, so 25. Going to multiply by 4. 3 times 4 is 12. So the decimal would be 0.12, and the percent would be 12%. And 3 out of 25 was the simplified fraction. Okay, that's independent. So all we do is take the simple probabilities and multiply them together for independent event. How I know it's independent is that the second part is not dependent upon the first part, because we're putting it back in the bag. Nothing's changing about the experiment. You've got the same amount of marbles each time.